This tech tip is on how to locate a node by node ID in a model using ANSYS Workbench Mechanical. I'm going to turn the presentation over to Sunil. Sunil, it's yours.
Thank you, Dan. So today's tech tip is necessary in cases when, for example, you have an error message or a solution-related issue that requires you to locate a node or an element. For instance, you may have a message that says that the limits of degree of freedom is exceeded at a particular node number, and there is a node number associated with it. So that's where in Workbench Mechanical this tech tip can be handy. And what we're going to look at today, 4 different ways you could do this. Just to kind of summarize those quickly before I go to the actual demo, you can actually turn the node numbering or element numbering display on if you have version 16 of ANSYS or newer. If you have 15.0 or a newer version, you could create a name selection based on a worksheet criteria. That's another way of doing this. Also, there is a very useful ACT extension called FE-Info that has been available since version 14.5, and that is really geared towards troubleshooting mesh and specifically nodes and elements, and does give a lot of handy tools besides finding the specific node and element numbers. Lastly, none of these methods that I mentioned so far are good for all types of elements, although they are good for majority of the elements. If you want to do very specific element types, such as contact or surface effect elements, none of these methods would show you the way to find those. And the only way to do that or identify those elements or nodes is to edit the ds.dat file, which requires some knowledge of APDL. All right. Having said that, let's look at these methods one by one. So for example, I have a 2-dimensional model here, and you see that I need to find, say, a particular node number or an element number as part of troubleshooting. I'm using version 16. I can simply go to annotation preferences and turn the node number on, and say I want to find element number 300. I can simply say, find me element number 300, and 300 to 300 is the range with an increment of 0. And I apply changes, and you see that sure enough, right here is our node number 300, and that allows us to look at exactly where the problem is. Likewise, I could do this trick with element numbers, and again, I'm going to choose an arbitrary element number, say element number 400 with the increment of 0, apply changes, and sure enough, here is my element number 400. So this is possible since version 16. Having said that, this is not always as easy as it looks. It's great for, say, 2-dimensional elements. But if you go to more of a 3-dimensional element where the node could be located inside, for example, this element inside, it can get a bit messy using this technique. So that's where our second trick to find a mesh node or a mesh element comes in handy, and this uses a name selection. The name selection, or for APDL users, the components can be easily created using a worksheet criteria, and that's the method that's suitable for identifying nodes and elements. In this case, for instance, I have a node selection or name selection that uses a criteria that adds mesh node, and I've arbitrarily chosen the node ID equals 5600. So this is going to find me a specific node which is 5600. And as soon as I click that on, the pink arrow here shows where the node is. And again, it's not easy to visualize this in a three-dimensional setting, but what you can do is turn the wireframe on and show mesh on, and that gives you then a better identification of where that node is exactly located. You can, just to make it more savvy or straightforward to identify different name selections, could also rename this to say node 5600. So that's how you do it with name selections. I can do a similar name selection, say for instance mesh element 5600 with almost identical scheme using a worksheet criteria, and that allows me to choose a particular element, which is in this case is element 5600. And when I click on that, you'll see that again, turning the wireframe and the show mesh on, it's going to show me the element. And in this case, actually the element representation is a little bit better. It actually shows all the edges and whatnot, so it's easier to identify that element within this model. So those are the two methods, the first two methods. The third one is a really nice implementation and available since version 14.5. It requires you to activate an extension called FE-info, and the as you see in this particular model, I have the FE-info extension loaded and installed and loaded. If you need more information about ACT extensions, we have a tech tip on ACT extensions that might help you through this process of loading a particular extension, and you need to find FE-info extension for the specific version of your workbench. That's an important thing to note. So the idea here is once you have the extension installed and loaded, it gives me a particular toolbar here that just has a whole bunch of features. And for instance, I'm just going to show this one where I can select a node by an ID, or I can give, as you saw, a whole bunch of IDs from files. So that's also possible. So if I choose select nodes by ID, I simply say 400 or something like that and select. And sure enough, it actually prints the node number and its exact coordinates here in the legend, but it also shows the 400 node displayed here. Actually, this is a, yeah, this is the node. So the node is highlighted here. And so it's a nice little tool that allows you to do that. In addition to that, it can not only give the elements, you can go to select elements, and select elements by ID would be the way to do it. But there are a whole other criteria that you can use to find a nearest node to, say, a coordinate, or find distance between two nodes or what have you. So these are pretty nifty features that are available for you with this FE-info extension. Now, just a reminder that either of these tools, or all these tools that we have talked so far, they are only good for the most structural element that actually are not special element types, such as say the contact elements or surface elements, which are really elements to facilitate some boundary condition of some sort or a contact of some sort. And those would not be found using any of these methods that we discussed so far, or including the ACT extension. And when you're in a situation where none of these methods is able to identify a particular elements number or node number, or when you try to identify it, it comes in empty. The only way you can find what that is by opening the solver file directory and looking at the ds.dat file. And when you open the ds.dat file, it's basically the background APDL input deck, and there you will be able to, again, with some knowledge of APDL, find the nodal information, associated coordinates, and then you have to scroll down to the element connectivity data and essentially search by the string for those that particular node or element. So that concludes this tech tip, and thanks for watching.